the next topic I am going to take up is integration of rational functions using partial fractions. Integration of rational functions using partial fractions. Now first of all, what is a rational function? A rational function is a function of the form nx over dx, where nx and dx are both polynomials. A function of the type nx over dx, where nx and dx both are polynomials, is known as a rational functions. And to integrate such functions, we generally reduce this function into partial fractions. And how to reduce this function into partial fractions? I'll just give you these steps. First step will be carry out division whenever possible. If division is possible, first step will be we will carry out division. Now when is division possible? If degree of numerator is greater than or equal to denominator, then division is possible. So if division is possible, we will carry out division and write this as numerator over denominator is equal to quotient plus remainder over denominator. This is the general rule, division algorithm. Now note, if degree of numerator is equal to degree of denominator. If degree of numerator is equal to degree of denominator, then we can avoid this division and write this directly as numerator over denominator is equal to coefficient of highest degree term in numerator over coefficient of highest degree term in denominator. Just write the coefficient of highest degree term in numerator divided by coefficient of highest degree term in denominator plus partial fractions. I will just tell you how to write these partial fractions in the next step. For example, if we have x minus 1 into x minus 2 into x minus 3 whole divided by x minus 4 into x minus 5 into x minus 6. Now what we note here is degree of numerator is 3. 1, 1, 1, and degree of denominator is also 3. So degree of numerator is equal to degree of denominator. So we need not carry out the division. Division in this case will be quite time consuming. First we will have to multiply these factors and then divide and then write it in this form. So if degree of numerator is equal to degree of denominator, we can avoid division and write directly as coefficient of highest degree term in numerator. Coefficient of highest degree term in numerator will be coefficient of x cube. Now in these factors, coefficient of highest degree term will be coefficient of highest degree term in this bracket is 1. So 1 into 1 into 1. If it is 2x minus 3, then quotient will be 2. And here we have again coefficient of x is 1, here 1 and 1. If it is say 2x minus 5, 2x minus 5, then quotients will be 1, 2, 1, 1, 2, 1. So write the quotient of highest degree term in numerator as well as denominator and plus partial fraction, plus partial fraction. So this will be 1 plus partial fractions. One more example, if say we have x cube plus 2x plus 1 whole divided by 2x minus 1 into x plus 1 into 3x plus 1. Then again degree of numerator is equal to degree of denominator. It is cubic. This is 1, 1, 1, 3. So degree of numerator is equal to degree of denominator. And so we can directly write quotient of highest degree term in numerator. Quotient of highest degree term, that is x cube. It is 1. And quotient of highest degree term in the denominator. There will be x cube in the denominator and its quotient will be 2, 1 and 3. because we will get the highest quotient on multiplying this with this with this. So this will be 2 into 1 into 3. You can directly write this plus partial fraction. This is equal to 1 by 6 plus partial fraction. So when degree of numerator is equal to degree of denominator, we can directly write as this and avoid division. So if degree of numerator is equal to degree of denominator, we write this as a quotient of highest degree term in numerator over quotient of highest degree term in denominator plus partial fractions. Now next step is factorize the denominator. Factorize this denominator into simplest possible factors. Factorize the denominator into simplest possible factors and combine the same factors at one place. If there are any factors which are same, we will combine them at one place. If there are any factors which are same, we will combine them at one place. So next step is factorize the denominator into simplest possible factors, combine same factors at one place. Now suppose we have the rational function 3x plus 1 over x minus 1 into x square minus 1. Then what we do is we factorize the denominator, that is 3x plus 1 whole divided by x minus 1 into, we can factorize this, factorize the denominator into simplest possible factors. So simplest possible factors of this will be x minus 1 into x plus 1. Now we have these two factors are same, so we will combine them at one place. 3x plus 1 over x minus 1 whole square into x plus 1. So this is factorize the denominator and combine the same factors at one place. Now third step is write a partial fraction corresponding to each factor in the denominator. Write a partial fraction corresponding to each factor in the denominator using the following table. If the factor in the denominator is a linear, if it is nx over L, numerator over L, then we will write a by L. Partial fraction corresponding to this will be a by L. If it is L square in the denominator, partial fraction will be a by L plus b by L square. If it is L square, it will be a by L plus b by L square. And if it is say L cube, if it is L cube, then what will be the partial fraction? It will be a by L plus b by L square plus c by L cube, and so on. And if it is a quadratic in the denominator, then partial fraction will be ax plus b over quadratic. It was linear in the denominator, linear is of degree 1. So we wrote constant, degree 0, 1 degree less. If it is linear, we will write constant. If it is quadratic, we will write linear. If the factor in the denominator is a quadratic, we will write ax plus b over quadratic. If the factor is q square, factor in the denominator is a quadratic square, then we will write ax plus b over quadratic plus cx plus d over quadratic square. And if it is quadratic cube, we will write ax plus b over quadratic plus cx plus d over quadratic square plus ex plus f over quadratic cube, and so on. So for example, in this case we will write this as, this is linear square, so we will write this equal to a by L, L that is x minus 1 plus b over x minus 1 square. This is linear square, so a over L plus b over L square plus, you can see the table on the side, and this will be c over linear. One more example, say we have 3 x square plus 1 whole divided by x minus 1 whole cube into 3x square plus 1. Then this can be written as a over linear. This is linear cube. So we will increase the powers 1 by 1 plus b over x minus 1 whole square plus now this is x minus 1 whole cube. So this will be c over x minus 1 whole cube. Now we have quadratic. So quadratic we will have dx plus e. For quadratic we will write a linear here. Dx plus e over 3x square plus 1. Write a partial fraction corresponding to each factor in the denominator. Another example, say x over x minus 1 into x minus 2 into 2x square plus 7 whole square. So this will be a over, this is linear, this will be a over x minus 1 plus b over x minus 2 plus, now this is a quadratic scale. So we will increase the power 1 by 1, cx plus t over 2x square plus 7 plus next will be ex plus f over 2x square plus 7 whole square. Now next step will be, once we have written the partial fractions corresponding to every factor in the denominator, we will multiply both sides by the denominator. First write partial fractions corresponding to each factor in the denominator. Then multiply both sides by the denominator. Now we will find these constants a, b, c, d. We will find these constants. And best method to find these constants will be, we will put each linear factor equal to 0, 1 by 1. Put each linear factor in the denominator equal to 0, 1 by 1. And if there are still some constants left, we will equate the quotient of highest degree term on both sides. If still some constants are left, we will equate coefficients of highest degree term on left hand side and coefficient of highest degree term on the right hand side. And again, if still some constants are left, next will be, we will equate the constant terms on both sides. We will equate the constant terms on both sides. And if still some constants are left, then we will equate the other degree terms. Then we will equate other degree terms. First will be put each linear factor equal to 0, 1 by 1. Next will be equate the quotients of highest degree term on both sides. Next will be equate the constant terms on both sides. And if still some constants are left, then we will equate the other degree terms. So write a partial fraction corresponding to each factor in the denominator using this table. Multiply both sides by denominator and then find these constants. First will be put each linear factor equal to 0. Second will be equate highest degree term. Then equate constant terms. And last will be equate coefficients of other degree terms. Now I take up some questions. First is evaluate the following integral. Now this is a rational function. So is division possible? No. So first step is not required. Second step is factorize the denominator into simplest possible factors and combine the same factors at one place. So we will factorize this denominator. This is x cube minus x square minus x plus 1. This can be written as x square is common. We have x minus 1 is common, x minus 1. So this is equal to x square minus 1 into x minus 1. But this can be factorized further. So we will write x minus 1 into x plus 1 into x minus 1 and combine the same factors at one place. So this can be written as x minus 1 whole square into x plus 1. And therefore 3x plus 5 over x cube minus x square minus x plus 1. Now in such questions, first is we will reduce this into partial fractions. Then we will solve the question of integration. Integration is not involved in these steps. First we are resolving this into partial fractions. So this will be equal to 3x plus 5 over x minus 1 whole square into x plus 1. Now write a partial fraction corresponding to each factor in the denominator. So we will write this as a over x minus 1 plus b over x minus 1 whole square plus c over x plus 1. This is how we will write these partial fractions. You can see the table on the side sheet. Next step is multiply both sides by the denominator. So we will multiply both sides by this denominator. So we will get multiply both sides by the denominator, that is x minus 1 whole square into x plus 1. So we will get this will cancel and we will get 3x plus 5. This is equal to, now multiply this term with this. So this will be a into x minus 1. X minus 1 will cancel. So only 1 x minus 1 will be left. X plus 1 plus b into. Now x minus 1 whole square will cancel. We will have b into x plus 1 plus c. C into this. X plus 1 will cancel with x plus 1. Only x minus 1 whole square will be left. So c into x minus 1 whole square. Now we will find these constants. And to find these constants, first is we will put each linear factor equal to 0, 1 by 1. So first is we will put x minus 1 equal to 0. So this implies x is equal to 1. So x equal to 1, so this will be 3 plus 5. This is equal to x minus 1 is 0, this will be 0. Plus b into x equal to 1, so this will be b into 2. And this will be 0. So we get the value of b. This implies b is equal to 4. So first constant is b equal to 4. Now put the other linear term equal to 0. Put x plus 1 equal to 0. So this implies x equal to minus 1. Now x equal to minus 1. So this will be minus 3 plus 5. And this is equal to, now x plus 1 is 0. So this will be 0. This is 0. So 0 plus 0 plus c into x equal to minus 1. So minus 1 is minus 2 whole square. So this implies 2 is equal to c into 4. Therefore c is equal to 1 by 2. So c is 1 by 2. Now only a is left. Now to find a, we will equate the coefficients of highest degree term. Equating coefficients of highest degree term on both sides. Now call this as 1, this as 2, this be 3, this be 4. Now quotient of highest degree term. So this is linear. This into this is quadratic. This. So highest degree term is x square. So we will equate the coefficients of highest degree term, that is x square. There is no term of x square on the left hand side. So this coefficient will be 0. From here we will get highest degree term. So multiply the coefficients of highest degree terms here. This is 1, this is 1. So a into 1 into 1. From here we will not get any term of x square. So leave it. And here we will get plus c into quotient of x is 1. So 1 square. There will be no highest degree term in this bracket. So we will leave it. From rest, if we are sure that we will get a highest degree term from this bracket, we will multiply the coefficients of highest degree terms in these terms. So what we do is we first ensure whether we will get the highest degree term from this term or not. If we will get a highest degree term from here, we will multiply the coefficients of highest degree terms in all the brackets involved. So this will be a into 1 into 1. We will not get any highest degree term from here. From here we will get a highest degree term. So this will be 1 square. C into 1 square. So this is easy and shorter, instead of expanding this and then equating the quotients of highest degree term. So this will be easy. So what we get is a is equal to minus c. A plus c is equal to 0. So a is minus c. This is equal to minus half. So a is equal to minus half. Clear? Now we substitute in 1 and obtain this integral. Therefore I is equal to integral. Now this term is equal to this. This term is equal to this. So this will be a. How much is a? A is minus half. Minus 1 by 2 into x minus 1 dx. First term is this. Plus integral b over x minus 1 also. This will be 4 over x minus 1 whole square. I am separating these terms. And c is half. Plus integral 1 by 2 over x plus 1. X plus 1 dx. So this term is equal to this and this is equal to this. A is this much, b is this much, c is this much, and we are separating the terms. Now integration of this will be equal to minus half is constant and integration of 1 over x minus 1 is log of x minus 1 plus 4 into this will be x minus 1 whole to the power of minus 2. So minus 2 plus 1 is minus 1 over minus 1. N plus 1 over n plus 1. Minus 1 by 2 log of mod x plus 1 plus c. It will be plus half and integration of this will be log of x plus 1 plus c. So we can combine these two terms at one place. We can write 1 by 2 log of this will be plus. So the x plus 1. This is minus, so this will go in the denominator. X minus 1. Clear? Minus 4 over x minus 1 plus c. This is the answer. This is how we do it. First is check whether division is possible or not. Here division was not possible, so first step is not required. Factorize the denominator into simplest possible factors. Combine the same factors at one place. Now write a factor corresponding to each factor in the denominator. Write a partial fraction corresponding to each factor in the denominator. Here factor is a linear square. So a over linear plus p over linear square. This is linear only. So we will write plus c over linear. Next is multiply both sides by the denominator. So when we multiply both sides by the denominator, we will get 3x plus 5. X minus 1 will cancel. We will get x minus 1 and x plus 1. Here x minus 1 whole square will cancel and we will get b into x plus 1. And here x plus 1 will cancel. This will cancel and we will get c into x minus 1 whole square. Now next is to find these constants. Now first we will equate each linear factor equal to 0 1 by 1. So put x minus 1 equal to 0, we get one constant. Put x plus 1 equal to 0, we get another constant. Now only one constant is left. So we will equate the highest degree term on both sides and we will get this constant. If you do not want to equate the highest degree term on both sides, you can put another value of x in this and generate a equation. For example, if you put x equal to 0, we haven't put x equal to 0, we have put x equal to 1 and x equal to minus 1. So put x equal to 0 on both sides. If we put x equal to 0 on both sides, what we will get? X equal to 0. So this will be 5 is equal to x is 0, x is 0. So this will be minus a. Minus a, x is 0, this will be p. X is 0, this will be c into minus 1 whole square. That is c. From here also we will get a and value of a will be same as this. So a will be b plus c minus 5. So this will be 4 plus c is half minus 5. So 4 minus 5 is minus 1. Half minus 1 is minus half, which is same as this. So if you don't want to equate the quotients of highest degree term, you can put any other value which has not already been substituted. We have put x equal to 1 and x equal to minus 1. So you can use another value. Easiest will be x equal to 0 and generate a equation. Either equate the quotients of highest degree term and then equate the quotient of constant term and get the remaining constants, or you can generate equations by substituting other values of x equal to 1 and minus 1. Put some other value of x which we have not substituted yet and get an equation and simplify this. You can also find the constant in this way. Now next is integral x over this. Again we will resolve this into partial fractions. Now first step is carry out division if possible. Division is not possible, therefore first step is not required. Second is factorize the denominator into simplest possible factors. These are the simplest possible factors, therefore this step is also not required. So we will directly write the partial fractions. We will write x over x plus 1 into x square plus 1 is equal to. This is linear, so this will be a over x plus 1 plus this is a quadratic. So we will write bx plus c over x square plus 1. Next is we will multiply both sides by the denominator. That is x plus 1 into x square plus 1. What we will get is we will get x is equal to. This will cancel and we will get x. A into x plus 1 will cancel with x plus 1. If we multiply this by this term, x plus 1 will cancel and we will get a into x square plus 1. Now multiply this term by this. So x square plus 1 will cancel and we will get bx plus c into x plus 1. Now let us say this as 1, this as 2. Now we will find the constants. First is equate all the linear factors equal to 0, 1 by 1. So there is only one linear factor. So first we will put x plus 1 equal to 0. That is x equal to minus 1. We will get minus 1 is equal to a into minus 1 whole square plus 1. And this will be x plus 1 is 0, therefore this will be 0. And we will get the value of a. So a will be equal to, this is 1 plus 1, 2. So a will be minus 1 by 2. Say this as 3. Now there are no other linear terms. So we will equate coefficients of highest degree terms. Coefficients of highest degree term, that is highest degree term in this bracket is x into x is x square, x square, x square. So this will be x square. There is no term of x square here, so this will be 0. There will be a term of x square here, so this will be a into 1. Plus linear into linear will again be a quadratic, so we will get a term of x square. So this will be highest degree term in this bracket is b. Quotient of highest degree term is b, and here it is 1. So we get b plus a equal to 0. Therefore b is equal to minus a is equal to minus minus plus half. So this is plus half. Now one more constant is left, that is c. So to find c, we will equate the constant term. Now constant term on left hand side is 0. So there will be a constant term. So a into 1. This will be a into 1. And constant term here is c plus c, and in this bracket constant term is 1. We will get a constant term from this by multiplying the constants. If say c is 0, if there is no c, then we will not get a constant term, because all the terms will be of bx square and bx. So there will be no constant term. Therefore this implies c is equal to minus a, and this is equal to half. Therefore 1 implies I is equal to, call this as I. So I is equal to A over this. So A is, how much you say? A is minus half. So minus half over x plus 1 dx plus integral bx. How much is b? B is half. So this is half x plus c is also half. So this is half over x square plus 1 dx. This is equal to minus 1 by 2 log of x plus 1. Plus 1 by 2 is common, and we get. Now we will separate this into two terms. X over x square plus 1 dx plus integral 1 over x square plus 1 dx. This is a complete integral because differential of x square is 2x. So what we will do is we will multiply this by 2 and divide this by 2. So this will be a complete integral, and integration of this is known, and we know it is tan inverse x. So this will be equal to minus 1 by 2 log of x plus 1 plus, open this bracket, this will be 1 by 4, this is a complete integral, so this will be log of x square plus 1, and half into 1 by a is 1, so integration of this is tan inverse x plus c. This is linear over quadratic. So we will express this linear in terms of differential of this quadratic, which is already expressed. Separate them and solve. So this is the answer. Now in this question, what we note is degree of numerator is 3 and degree of denominator is also 3. So in such questions we can directly write x cube over x minus 1 into x minus 2 into x minus 3 is equal to coefficient of highest degree term in numerator, that is 1, over coefficient of highest degree term in denominator. It is x cube. Here we will get x cube. So coefficient of highest degree term will be 1 into 1 into 1. So this will be 1. Quotient of highest degree term in this bracket into this bracket into this bracket. It is a cubic. So we will get 1 plus partial fraction, that is a over x minus 1 plus b over x minus 2 plus c over x minus 3. And next step is we will multiply both sides by the denominator. What we will get is we will get x cube is equal to, now multiply by this. So this will be x minus 1 into x minus 2 into x minus 3 plus, now multiply this by the denominator. So x minus 1 will cancel with x minus 1 and we will get a into x minus 2 into x minus 3 plus b into, now x minus 2 will cancel with x minus 2, we will get x minus 1 into x minus 3. So x minus 1 into x minus 3 plus c into, now multiply this with this, what we get is x minus 3 will cancel and we will get x minus 1 into x minus 2, x minus 1 into x minus 2. So we get this identity. This is 2. Now to find these constants, we will put each linear factor equal to 0, 1 by 1. So first we put x minus 1 equal to 0, that is x equal to 1. So what we get is x is 1 and this will be 0, x minus 1 0, x minus 1 is 0. So we will get only this term. So this is equal to a into 1 minus 2, that is minus 1, 1 minus 3, that is minus 2. So this implies a is equal to 1 by 2. Now we put x minus 2 equal to 0, that is x is equal to 2. So 2 2s are 4, 2s are 8. So 8 is equal to, now x minus 2 is 0, this term will be 0, this will be 0, this will be 0, only this term will be left. So we will get b into, x is 2, so 2 minus 1 is 1 and x equal to 2, 2 minus 3 is minus 1. So this implies b is equal to minus 8. This is minus 1, take this to the other side, we will get b equal to minus 8. Now we put x equal to, x minus 3 equal to 0, that is x is equal to 3. So 3 3s are 9, 3s are 27. So this will be 27 is equal to, now x minus 3 is 0, therefore this is 0, this is 0, this is 0, we will get only this term. C into 3 minus 1, 2, 3 minus 2 is 1. So we will get C into 2 into 1. So this implies C is equal to 27 by 2. So we have found all the three constants. Now we substitute in 1 and integrate it. Substituting A, B, C in 1 and integrate. Integration of this is this. Let this be I. So integration of this will be I. So I will be equal to integral. Now integration of this will be 1 dx plus A into integral of 1 over x minus 1. So A is 1 by 2 into integral of 1 over x minus 1 dx plus B. B is minus 8. So this will be minus 8 integral 1 over x minus 2 dx plus C over x minus 3. C is 27 by 2 plus 27 by 2 integral of 1 over x minus 3 dx. So this is equal to integration of this is x plus 1 by 2 integration of this will be log of x minus 1 minus 8 integration of this is log of x minus 2. So this is log of x minus 2 plus 27 by 2 into log of integration of this is log of x minus 3 plus C. So this is the answer. Now in questions where the denominator is the product of only linear vectors, all these vectors are linear. For such questions we have a shortcut. I will now discuss that shortcut. What we do is we will write x cube over x minus 1 into x minus 2 into x minus 3. This is equal to 1 plus x minus 1 plus x minus 2 plus x minus 3, and find these constants by direct substitution. The method is, what we will do is we will hide this x minus 1 in this term. Hide x minus 1 and put x minus 1 equal to 0, that is x equal to 1 in the rest of the term. Hide this and put x minus 1 equal to 0, that is x equal to 1. Put x equal to 1 in the rest of the term. For this we will put x minus 2 equal to 0, that is x equal to 2. Hide this and put x equal to 2 in the rest. For this we will hide x minus 3, so x minus 3 will be hidden and we will put x equal to 3 in the rest. And we will directly get these constants. We need not carry out this procedure. So for this, hide x minus 1 and put x equal to 1 in the rest. So this will be 1 cube, that is 1 over 1 minus 2 into 1 minus 3. For this, hide this and put x equal to 2 in the rest. So this is 2 cube over 2 minus 1 into 2 minus 3. And for this, we will hide x minus 3 and put x equal to 3 in the rest. So this will be 3 cube whole divided by, this will be 3 minus 1. And this will be 3 minus 2. 3 minus 2. So we get all these constants in a single step. So rule is, for this, hide x minus 1 and put x minus 1 equal to 0 in rest of the term. For this, we will hide x minus 2 and put x minus 2 equal to 0 in the rest of the term, in rest. And for this, hide x minus 3 and put x minus 3 equal to 0 in the rest of the term. We will directly get these constants. So this is equal to 1 plus, this is x minus 1. Now this is 1, this is minus 1 minus 2. 1 over minus 1, 1 over minus 1 into minus 2. Plus 2 2s are 4, 2s are 8. 8 over 2 minus 1 is 1. This is 1. 2 minus 3 is minus 1. Whole divided by x minus 2. Plus 3 3s are 9, 3s are 27. So this will be 27 over. 3 minus 1 is 2, 3 minus 2 is 1. So this will be 2 over x minus 3. So what we get is 1 plus, this will be 1 by 2. 1 by 2 over x minus 1. Plus, this is minus 8 whole divided by x minus 2. And in this case we have 27 by 2 whole divided by x minus 3, which is same as this 1 plus half x minus 1 minus 8 x minus 2 plus 27 by 2 x minus 3, which on integration gives I is equal to x plus 1 by 2 log of x minus 1 minus 8 log x minus 2, because this is same as this, plus 27 by 2 log of x minus 3 plus c. So this shortcut is available for questions where denominator is product of only linear factors. Then we have this shortcut.